See, we are discussing about P block elements. So, in P block elements, some important concepts we are discussing compounds. Now, we discuss about nitric acid. So, nitric acid HNO3. So, that is the preparations. See, so this Ostwald's process. So, Ostwald's process is there. Next, second, Birkeland-Eyde process. So one is Ostwald's Birkeland-Eyde process. First one, Ostwald's process. So in Ostwald's process, what you are taken ammonia. So ammonia is treated with oxygen. You are heating. So then what happens? Nitrogen react with oxygen. You will get NO. Next, hydrogen react with oxygen. You are getting H2O. So balance that one in what way? 4 NH3 5 4 12 means 6H2O plus some energy also coming outside. So here NO is coming in first step. This NO again heated with oxygen. So you are getting NO2 gas. That is step 2. Next, NO2 gas you treated with water. So you are getting HNO3. Again NO also forming. So that balancing. So 3NO2 plus H2. So that is HNO3. 3 to the 6. So 2HNO3. So now this NO is again used in the second process. So there is no wastage. So you can prepare HNO3. So that is Ostwald's. Next, Birkeland-Eyde process. Second. So Birkeland-Eyde. So here nitrogen react with oxygen. So highest temperatures you are getting NO. Next again NO is taken in oxygen. So you are getting NO2. Similar process only. Now NO2 treated with water. So you are getting HNO3 plus NO. So again it is used in a second step. So step by step you can see that is a Birkeland-Eyde. So mainly important in Ostwald's process you are taking ammonia, Birkeland-Eyde process nitrogen and oxygen we are taking. Next, you see the chemical properties. So chemical properties you take HNO3. So direct you can heat, otherwise in the presence of sunlight. So what happens? It is oxidizing agent. So that's why what happens here? It is dissociated. NO2 plus water plus nascent oxygen. So that means oxygen gas is liberated. So you balance that one. Next, it is acid. HNO3 acid means readily react with bases. So suppose HNO3 react with base. So calcium oxide. So 2 moles. You are getting what? CaNO3 taken twice plus H2O. So any bases you can take. So NaOH. Otherwise calcium hydroxide. So any bases you can easily react. Next, it is acting as what? Oxidizing agent. So HNO3 acting as a oxidizing agent. So in what way it will show oxidizing agent means HNO3 you can take. So you heat this one. So heating means H2O is going outside. Next remaining is what? N2O5. So that is I am writing 2NO2 plus a single oxygen is coming. So otherwise HNO3 2 moles we are heated. So water is coming outside here. 2 moles of NO you take, 3 nascent oxygens. So this is more powerful because of 3 oxygens are coming here, 1 oxygen. So means these are supplying nascent oxygen. So these are acting as strong oxidizing agents. So that's why what happens is this, the HNO3 react with sulfur. You are getting H2SO4 react with phosphorus H3PO4. So like anything. So H2S. So S is minus 2. So sulfur is coming outside. Otherwise SO2. Otherwise SO3. So oxidizing agent it is acting. Next, if famous, already we seen in the previous class, nitrogen oxides, the possibilities. How that is coming. So copper plus HNO3 they are heated. So that is 1:4 ratio. 1:4 ratio you are getting N2O4. Otherwise 2 moles of NO2. 2:6 you are getting N2O3. Otherwise NO plus NO2. Next 3:8 you are getting N2O2. Otherwise 2 moles of NO. 4:10 you are getting N2O. Next 5:12 you are getting N2. So like that combinations you are getting. Next, in the organic chemistry also this is a famous. So in what way? So benzene react with concentrated HNO3. So you are getting nitrobenzene. Next, see benzene react with concentrated H2SO4 in the presence of same. This is only concentrated in the presence of concentrated H2SO4. So you are getting nitrobenzene. So this is what nitrating mixture. So 1:1 ratio nitrating mixture. Next, suppose butane. So butane is treated with concentrated HNO3. So here carbon-carbon bond is also breakages. You are getting a 4 carbon nitro compound. Next 3 carbon nitro compound. Next 2 carbon nitro compound. And 1 carbon nitro compound also you are getting. So this is important. Next, suppose you take toluene. Toluene treated with concentrated HNO3. So oxidizing agent. So that's why you are getting benzoic acid. So alpha hydrogens. So that is next proteins. So proteins react with concentrated HNO3. So you are getting a xanthoprotein. So this is what yellow color. So if our skin is touches with HNO3, that yellow color it become high. Next glucose. So glucose react with HNO3. Concentrated HNO3 strong oxidizing agent. So you are getting gluconic acid. So very more and more important about HNO3. Next, HNO3 famous compound, that is aqua regia. So what is aqua regia? See, 3 moles of HCl, 1 mole of HNO3 combination, you called as aqua regia. What is the importance of this one? See, the noble metals. Noble metals. What are noble metals? So iridium, platinum, gold. So these are dissolved in it. Otherwise, a reaction takes place in this. So that who is reacted means that is a nation to chlorines. See, what is that? You take HNO3 plus 3 moles of HCl. So what happens here? See, 3 hydrogens, 4 hydrogens. 4 hydrogens means 2 water molecules will go outside. So 2 water is gone. So here NOCl. So NOCl also going outside. Next, 2 nation to chlorines. NO2Cl, I think 2 NOCl. So nation to chlorines are available. So because of that, nation to chlorines are reactive with gold. Gold react with 3 nation to chlorines. You are getting AuCl3. Next, suppose platinum you are taken 4 nation to chlorines. You are getting PTCl4. So that nation to chlorines is more reactive. That is only reactive with so next compound discuss with P4. See, phosphorus in the nature, phosphorus is available P4 only. So that is which structure? Tetrahedral structure. It is possible. Bond angle is what? 60 degrees. Structure is tetrahedral. So tetrahedral means bond angle 109 degrees 28. Then only stable. So because of this instability, it is more and more reactive. So that chemical properties you can see. So in that chemical product, generally what? So with oxygen. So phosphorus react with oxygen. Chemical properties. So what you will get? P2O3 or P2O5. So this is also you can write P4O6. Otherwise P4O10. It is available. Next, if you treat it with chlorine, you are getting what? PCl3 and PCl5. Ground state means +3 oxidation state. Excited state is so PCl5. You are getting. Next, so famous NaOH. So NaOH in the presence of water. So you are getting what? Phosphine. So this is important one. So you take 3 moles of NaOH, 3 moles of water. The PH3 is possible as well as so NaH2PO2. So this compound is sodium hypophosphite. Very, very important. That one. See, suppose phosphorus treated with HNO3. Phosphorus treated with HNO3. So it is oxidizing agent. So NO2 gas is coming. NO otherwise NO2. So that is supplying oxygens to the phosphorus. So then what happens? Phosphorus become as P2O3 or P2O5. And water is also coming. So water is there means P2O3 is giving what? H3PO3. If P2O5 water, you are getting H3PO4. So similar manner, you can take H2SO4. H2SO4 is what? Oxidizing agent. So which gases are coming means SO2 gas is a major. So SO3 also depending on temperature. Again same thing. Phosphorus react with oxygen P2O3 or P2O5. Then again they are react with water. You are getting H3PO3 or H3PO4 is possible. Next, this phosphorus excess is happened. Which diseases came? Phosphorus excess is happened in our body. So that is what? Fossy jaw. So some tooth, that jaw disturbance, that is a fossy jaw. One disease is observed. Next, compound is PH3. So the phosphine. So how we can prepare? So now only we see one. See phosphorus. Phosphorus react with NaOH. So you are getting 3 moles of NaH2PO2. Very important equation. Next PH3 is possible. So sodium hypophosphite. Next phosphorus related compounds. So phosphorus related compounds, you take aluminum phosphide. So it is +3 -3. So it is connected with H plus. H plus means you can take H2SO4 or HNO3 or water. Any H plus compound you add. So you are getting a PH3. Phosphine is available. Next, acid. So H3PO3. Acid we are heating. So your answer is ic acid. H3PO4 plus PH3. This is a disproportionation reaction. 4 moles, 3 moles. Here, +3 oxidation state. It is a +5 oxidation state. -3. +3 to +5 oxidation. +3 to -3 reduction. So that's why it is called as a disproportionation. So disproportionation reaction. So these are the important preparations of phosphine. Next, what will be the chemical properties? So chemical properties can take a phosphine, direct you heat. So direct you can heat, otherwise, so with oxygen you can heat, otherwise with chlorine also. Phosphine is what? Base. Base means it is react with HCl, HNO3, H2SO4, acids also. So if anything, oxygen contained compounds, N2O, oxygen supplied compounds. So we are heating. So phosphorus is separated, hydrogen gas is separated. So with oxygen, if you are heated with oxygen means phosphorus, you are getting P2O3 or P2O5, and hydrogen means water will be eliminated. So chlorine you are taken, so PCl3 or PCl5 is getting, next HCl is eliminated direct. Next HCl. HCl is there means acid, so you are getting a phosphinium chloride. So phosphinium sulfate or nitrate, PH4NO3. Next, you are taking this one. So lowest temperature we are heating means phosphorus is separated. Water you are getting. So phosphorus is separated. Nitrogen gas is coming outside. H2O. So otherwise you can heat more. So H3P is there. So oxygens it is supplying. So PH3 react with 4 moles of N2O. Then what happens? So H3PO4 plus 4N2. Depending on the temperature and the logic manner, you can do this one. See, next compound, phosphorus oxides. See, phosphorus oxides. So, phosphorus is +3 in the ground state. So, oxygen -2. You are getting a P2O3 compound. So, in the nature, phosphorus is available at tetraatomicity. So, that is why P4O6. P plus 5 is the excited state. Oxygen -2. You are getting a P2O5. So, you can write a P4O10 also. So, how you will get phosphorus? Oxides P4 directly you heat with high temperature of oxygen, so you are getting P2O3 and P2O5. So otherwise any oxygen supplying agents, so nitrogen is coming outside, you are getting a P2O3 or P2O5. So these are the preparation of the phosphorus. Next, chemical properties, if you see. So otherwise P2O3 we are heating with oxygen, you will get a P2O5. So reverse also, you are heating with high temperature means oxygen separated, so P2O3 possibility. Next, if you see the chemical properties. So the chemical properties, so P2O3, you take P2O3 is heated with oxygen, you are getting a P2O5, the possibility. Next, P2O3 treated with chlorine. So then what will be the possibilities? So phosphorus, oxygen, chlorine combination. So you are getting what? POCl3. So POCl3 is possible, that compounds. Next, the important P2O3 or P4O6. Cold water. You are heated with cold water. Your answer is H3PO3, phosphorus acid. Suppose P4O6, you are heated with hot water. So that is the next. So that means we are heating phosphorus. So then it becomes as phosphoric plus P3. So that cold water and hot water is very important concept. Next, chemical properties of P2O5. So P2O5, so treated with water. So your answer is H3PO4. So you are getting a phosphoric acid. Next, suppose you are treated with H2SO4. So P2O3 treated with H2SO4. So water is eliminated, SO3 coming outside. So P2O5 is what? A dehydrating agent. So you treated with HNO3. So what happens? NO2 gas is coming outside. P2O5 is taken water. Suppose acetic acid. So you take a CH3COOH treated with P2O5. So 2 moles you can take CH3COOH. Here HOH, water is eliminated. So always you remember dehydrating agent. So you are getting acetic anhydride. So that is. Suppose P2O5 is treated with water. P2O5 treated with water in the presence of hydrogen peroxide. What will be the answer? See, P2O5 react with water. What is your answer? H3PO4. So H3PO4, now you are using water. H2O2, hydrogen peroxide. So you will get H3PO5, peroxyphosphoric acid. So the logical extension only. Suppose P2O5 treated with carbon. What happens? So carbon is what? Strong reducing. So oxygen is eliminated. So you are getting a P4 plus carbon monoxide, otherwise carbon dioxide. So like that logical equations you can think. Next, one important question in phosphorus oxides, that is pentoxide. What is the oxo acids? H3PO2, H3PO3, H3PO4, H3PO5. So hypophosphorus, phosphorus, phosphoric, peroxyphosphoric. Next H4P2O5, H4P2O6, H4P2O7. So this is pyrophosphorus, hypophosphoric, pyrophosphoric. Next HPO2, HPO3. So metaphosphorus, metaphosphoric. So these are there. Suppose you can take these three. So P2O5, P2O5 treated with water, you are getting metaphosphoric acid. So now it is treated with water, you are getting pyrophosphoric acid. Now you treated with this one water, you are getting phosphoric acid. So P2O5 treated with water, your answer is HPO3. So in examination they will put A. Next to water, you are getting H4P2O7 pyrophosphoric acid. Now it is treated with water. Last you are getting H3PO4C. Otherwise reverse also. H3PO4 phosphoric acid is heated. What is your answer? Pyrophosphoric. If it is heated, you are getting metaphosphoric acid. It is heated, so your answer is P2O5. So they will ask either here to here or here to here. Very, very important. Next, phosphorus chlorides are important here. So P4, phosphorus treated with chlorine. So you are getting PCl3 and PCl5. See, PCl3 treated with chlorine, you will get a PCl5. So what are that importance? In the organic chemistry, these are very important. CH3, CH2OH treated with PCl3. Your answer is CH3, CH2Cl plus H3PO3 is the byproduct. So similarly, acid also CH3COOH treated with PCl3. So you are getting acid chloride plus H3PO3. Next PCl5, you are treated alcohol treated with PCl5. You are getting CH3CH2Cl plus POCl3 plus H2O or HCl, not so HCl. POCl3 is the byproduct. Similarly, you take acid. Acid you are treated with PCl5. So same. So you are getting acid chloride plus POCl3 plus HCl are the byproducts. Here byproduct is H3PO3. Here byproduct is POCl3 plus HCl. That are important. Next, PCl3 treated with water. So PCl3 treated with water. So you are getting water. Cl is exchanged, OH is coming. So you are getting H3PO3. So PCl5 treated with water. You are getting H3PO4. So here phosphorus acid, there phosphoric acid. So PCl3 treated with oxygen. What is the product? So POCl3 is possible. Next, the solid PCl5 is important here. Solid PCl5. So 2 moles of PCl5 is available as PCl4 plus and PCl6 minus. So solid PBr5. So it is observed as PBr4 plus and Br minus. See, another important PCl5. Suppose you take aldehyde treated with PCl5. So one O replaced with two chlorines, you are getting ClCl. So that is a geminal compound. So in the organic chemistry, so very important that PCl3 and PCl5.